All right, the first thing it asks you to do is to draw a Venn diagram. So this is going to look just like it does in your book. And if you have your books, you're welcome to use that. But you do have your rectangle, and it's divided into rational and irrational. A couple things I want to point out that people usually forget. They forget to tell me that these are all real numbers, all right? They are all real numbers. And then we have the rational numbers and we have the irrational, and you can label it however you want, the Q or the Q in prime, or you can say rational, irrational if you want to. You can write the word. And then within those, you do have your circles. So you have your irrational really doesn't have anything else. He's kind of on his own there. But the rest of them, you do have circles. You have your integers, whole, and natural numbers that happen. And so you want to create your Venn diagram from that. And you want to label all of them as well. And mine's going to have to be bigger to stick them where I need to. But all right. And again, you're welcome to use your names or your letters, whichever works. Or if you need to draw an arrow. Mine's a little small, so I don't know if it's going to let me make this bigger, but we'll see. Yeah, it's not going to let me make anything bigger here. There. Okay. Then it wants you to tell what they're in. So two things happen here. It says, put it into the innermost set to which it belongs. Your answer key will actually just show you what it belongs to. So irrational and real is what this belongs to. So if I were to have to put that up there, I would actually just put it in the irrational. So I would put square root of 33 right here. The -9, the innermost one. So in this, your answer key is going to show you it goes in integer, rational, and real. But the innermost one that it goes into is this one right here. So I'm going to say that this is going to be in this little guy right there in my integer set. Okay? And so that's what this is going to look like. You're going to draw the Venn diagram, and then you're going to place your numbers where they go within the Venn diagram. All right, so remember, subtraction is adding the opposite. So you may find it easier to change this to an addition problem. You never change the first guy. He's negative, he stays negative, okay? So we have a -5 minus 2. If you can just subtract that and you're good, -5 in the negative, 2 more in the negative, that's -7. That's one way to do it. Or you can change this to adding the opposite, and you can see that you have -5 plus -2. And you're just going to add those and keep the sign, which gives you that -7. So you'll see that 7 and 9 are very similar. They look different, but when you change it to adding the opposite, -9 is the same concept. You're adding two numbers that have the same sign, a -4 plus a -5. You just add them and keep the sign. So you're going to get -9. All right. For 11, you have different signs, so you're going to end up subtracting. Again, you are welcome to add or subtract as mixed numbers, but I will say that borrowing is a little bit of a crazy issue when you have mixed numbers. And so if you have any question about borrowing with mixed numbers, you want to change it to improper fractions. And so if you'll recall, when we change it to an improper fraction, we just multiply. 5 times 1 is 5, plus 1 is 6, -6 over 5. Plus 5 times 1 is 5, plus 3 is 8, 8 over 5. So now you see that we have one positive and one negative. We're going to subtract and keep the sign of the larger. So 8 minus 6 is 2. Remember, if it already has a common denominator, or if you have changed it to a common denominator, you don't add and subtract your denominators. That is your common denominator. And because my 8 was my larger and it was positive, my answer is going to remain positive 2/5. Positive 2/5. So that first one we had a common denominator. This one we do not. So we have my 2 over 3 minus my 1 over 2. 2/3 minus 1/2. Because I do not have a common denominator, I need to get a common denominator. What is my least common multiple between 3 and 2? 6. So to get this 3 to a 6, I multiply by 2, which means I multiply the top and the bottom by 2. All right, so I have 4 over 6. So 2 parts out of 3 is the same as 4 parts out of 6, right? So I haven't really changed it. I just made the denominators to be a different denominator. And then I'm going to do the same thing with the second one. To get this 2 to a 6, I multiply by 3, which means I multiply the top and the bottom times 3. So 1 over 2 is the same thing as 3 over 6. All right? So everybody knows that if I have 6 pieces and I have 3 of them, I have half of it, right? That's why they're the same. Now that they are the same, first of all, I can see that the 2/3 is bigger than the 1/2. If you didn't already know that, that's easier to see when it's common denominator. And now I'm just subtracting, right? 4 minus 3. So 4 minus 3 gives me a 1. I've already gotten my common denominator of 6. So my answer is just 1 over 6 because my 4 was bigger. Any questions on that? And then, of course, we are going to have decimals. All right? Decimals work the same. I have 1 positive and 1 negative. So now I'm going to subtract. For decimals, I'm just going to put the bigger of the 2 on the top, the smaller of the 2 on the bottom, and subtract. 7 minus 5 gives me 2. Remember to bring down this decimal right here. 3 minus 3 is 0. Which was larger? The positive was larger, so my answer is going to be positive 0.2. Positive 0.2. And then you may have some that have multiple addition and subtraction. In this case, they're all negatives. A negative plus a negative plus a negative. Is my answer going to be positive or negative? Negative. Twofold, right? You're adding numbers with the same sign. Add and keep the sign. If you think of it on a number line, you went in the negative, you went in the negative, and you went in the negative, right? And so if you went, every time you moved, you went in the negative, your answer should also be in the negative, right? So you're just going to add them. 3 plus 6 plus 8. That's going to give me 17. And because they were all negative, my answer is negative 17. So the first thing I'm just testing you on, I'm hoping that you all know your math facts. And so I'm not going to give you any ginormous numbers, right? I'm really testing you on the concept of multiplying positives and negatives, right? And so I'm really looking for, do you know how to multiply them and do you know if it's positive or negative? So hopefully we know how to multiply 5 and 5. That's 25. And now I'm going to look at my signs. I have 1 negative sign. So is my answer positive or negative? Negative. And so my answer is going to be negative. If I had, by the way, so if I look at 35 on this one, and I have -2, -3, +3, and +4, without actually telling me the answer, how do I know if the answer itself is going to be positive or negative? Jared. Not Jared. Sorry. Jaden.
Because the positive and positive times each other's negative and negative times each other.
Right. So I have 2 negatives, right? My answer is going to be positive. That's an even number of negatives. What if I had 3 negatives? My answer is negative. If I have 4 negatives, positive, right? And so before you even get to your answer, you can figure out if it's going to be positive or negative. And then once you figure out if your answer is going to be positive or negative, you only have to worry about the multiplication piece of it. You don't even have to worry about the end piece. Go ahead and write your positive or negative and then just figure out the multiplication. All right, so when I multiply fractions, I literally just multiply across. What I can do before I multiply across is I can do what? Cross cancel. In this case, can I cross cancel anything? Yes, I can cross cancel the 2 and the 12. That's going to be a 1 and a 6, right? And so I have -3 over 1 times -6 over 7 because I reduced that 2 and 12, right? You don't have to rewrite it when you're doing the problems. I'm just rewriting it so you can see it. Is my answer going to be positive or negative here? Positive. And so I can just multiply across 3 times 6, 1 times 7, 18 over 7, and it is positive, right? You do not have to get a common denominator. You're just multiplying. You only have to get a common denominator when you're adding or subtracting. All right? But I'm just going. So division is the same. I'm really looking for, with the whole numbers, like 45 over 9, I'm assuming you know how to divide that. Now I'm going to try to find out, do you know if it's positive or negative, which this is nice because it's both positive, right? So you're going to do the same thing with these. I have 2 positive numbers. My answer is going to be positive. And then I just have to worry about dividing 45 by 9, which hopefully we all know is 5, right? Positive 5. The more complicated ones are going to be the ones like 43 and 45. Anytime you're dividing with fractions, you want improper fractions. You do not want to divide with a mixed number, all right? Because you're going to probably end up dividing wrong. So the very first step on 43 is just to make sure I have both fractions, not mixed numbers. 3 over 8 is already a fraction. I'm going to leave it alone. Divided by this, I have 8 times 3. 8 times 3 is what? 24 plus 1 would be 25. So I have negative 25 over 8. And this is my division problem. So now I'm going to do my keep, change, flip process. I'm going to keep this 3 over 8. I'm going to change this from division to multiplication. And I am always going to flip my second guy. Instead of negative 25 over 8, it's negative 8 over 25. All right. And then I'm going to check, can I cross cancel? If I can, I'm going to do that. Once I do that, I'm going to multiply across. Can I cross cancel here? Yes, I can. 8 and 8. That's beautiful, right? That's nice of them to give me that. Now I'm just going to multiply across. 3 times 1 is 3. 1 times 25 is 25. I had 1 positive and 1 negative. What is my answer? Negative. Negative 3 over 25 is my answer there. Negative 3 over 25. So they will be set up like this, where you go across with your division sign. And they could be set up like 45, where they are divided with a fraction sign, all right? When you divide with a fraction, you keep the top. Negative 1/3 stays the same. You change that division line to a multiplication, and you always flip the bottom. The bottom was 4 over 5. We're going to flip it to 5 over 4. Once you do this, same thing as always. Can I cross cancel anything? Once I do that, multiply across. Can I cross cancel here? I cannot. 1 times 5 is 5. 3 times 4 is 12. 1 positive and 1 negative, right? So my answer is going to be what? Negative 5 over 12. All right, so we'll do 41. And then I'm going to let you work on your own for a few minutes. If you come across one you don't know how to do, circle it, because I'm going to do answers at the end, like questions and answers. But I am going to, in a few minutes, give you the answer key, so you can also check your work. All right, so this is going to be set up similar to the one that we did with the mixed number. We're going to keep the first guy 1 over 10, multiplication, and we need to change this to an improper fraction. So 9 times 3 is what? 27 plus 4. So we have 31 over 9. So we're going to flip that to negative 9 over 31, right? Can I cancel anything? No. I cannot. So he ends up being rather large. 1 times 9 is 9. 10 times 31 is 310. And is my answer positive or negative? Negative. Negative. And that is, believe it or not, my answer. I cannot reduce it. All right. If you can't cross cancel, you probably won't be able to reduce it. Now, there are times when you just don't see that you could have cross canceled. So you always want to double check and make sure you can't reduce it. But remember, your little trick is like, if it's divisible by 3, then when you add up the digits, it should be divisible by 3. So I automatically know that 310 is not divisible by 3, because 3 plus 1 plus 0 is 4. That would have to be divisible by 3 for that to work. So